Mm, hello.
Hello.
Yeah. So the live
Hi.
session starts. So hi everyone. Good evening. I hope you are all doing fine. So in this workshop, we are going to start by an introduction about our guest, which is Arpita Gupta, and she uh, is the live. It's live, right? So 1 second. Yeah. So here is our guest, Arpita Gupta. She is working at GreyOrange and a former machine learning intern at Perplex AI. And she is also a AI geek like us. And we are all here for our workshop and session. And she will give us some tips and tricks about machine learning and give us some information related to it. So now I would like to hand over this session to Arpita Gupta. So hope you all enjoy this session. Thanks.
Thank you. Thank you so much for such a nice introduction. So, hi everyone. So, hello everyone. My name is Arpita Gupta, and as you all know, I am a machine learning enthusiast like you. So, in today's session, I'll be mostly telling you people about the basic stuff of machine learning and how machine learning works, how you can get started to you can get a kickstart in this technology. So, just give me a minute. I'll sort out my screen. There's a network issue out there. Just give me a minute. Hello. So, let me start with sharing my screen and like getting started with the session. Sorry for the delay. So here we go. I hope you people are able to see my screen. So let's get started. So as we all know, this session is mainly for the people who really want to get started in the domain and who want to get started with machine learning, who really want to kickstart. So in today's session, I won't be much formal. I have most of the content on my mind and a few of the content on the presentation. I'll try my best to help the people out there, and I'll try that I'll help the community out there. So let's get started. So, talking about machine learning is basically a domain which helps us to just it's artificial intelligence at the end of the day. So machine learning is something that a machine we are teaching a machine how to learn from the previous experiences and data, and then predict something on the similar kind of data in future. For example, a very good analogy would be, like for example, take the example of a baby. A baby, when he or she is born, he knows nothing. He knows literally nothing. He knows nothing about the world, nothing about the language, nothing about the behavioral traits. But when he grows up slowly, he gets his or her experiences. He learns from the observations and the peers around him, and then eventually he's able to learn the language, the behavioral traits, and all. So that's a very good analogy for machine learning. That's how machines learn. That's how we teach our computers. We basically, a baby learns from his or her experiences, and in case of machines, the algorithms or the computer learns with the help of the data which we give the computer. So yeah, this is a very layman definition of machine learning. I hope everybody would be able to get it. So a very formal definition of machine learning is also here. It is that machine learning is an application of AI that provides systems the ability to automatically learn and improve from the experience without being explicitly programmed. Like there's a very fine line here, that without being explicitly programmed. So I'll cover that in the next slide. I have an analogy for that as well. But talking about this formal definition, basically it is an application of AI that provides the system. Systems means the computer, the ability to automatically learn and improve from the experience. So like a machine or an algorithm learns from the experiences as well as the data which we give it. So it gets the data, it learns from the data, we train our model or algorithm on that data, and then eventually it gets insights or patterns out of that data, and eventually we are able to get insights of out of that data, and the computer has learned and it is able to replicate the human intelligence on the basis of that experiences. So that would be a formal definition of machine learning. So here is an analogy. It would make you understand better. For example, in traditional programming, what we do write rules, we give data to our algorithm, and eventually we get answers. Very common example would be, for example, we want to like check if a number is even or not. So what would we do? We would write some sort of if else code, and then eventually it would give us, it would like give us the answers. For example, if you want to know a number is even or odd, we'll write if, we'll write else, and then eventually it will give us an answer. When we give it an input, we give it the data, we give it the rules, and it gives us the answers. But on the other hand, in case of machine learning, this is not the case. We give it the answers, we give it the data, and then it gives us the rules. So a very coming to the previous example, if we would give the machine, the algorithm, some set of even numbers, and we'll tell the machine that these are even numbers, and we'll give the machine some set of odd numbers, and we'll again tell the machine that these are odd numbers. Like in technical terms, these answers of the data are basically called as labels in supervised learning. But for the beginners, I'm using the term answers. So it's like we give the answers to the machine, and then eventually it outputs rules from that. So like what are rules? Rules are the patterns and the insights which our machine has extracted from that data. So that's pretty much cool. That's the beauty of machine learning, I would say. So yeah, coming to the types of machine learning is broadly classified into three types. That is supervised, unsupervised, and reinforcement learning. So yeah, so talking about the supervised learning, that is the broad domain I have worked till now, and I'm mostly working on supervised learning right now. I love it. So supervised learning is just the kind of learning I explained to you, that we give data to the algorithm, it learns from that data, extracts from those insights, and then gives us the predictions. For example, you can take the baby example, or you can take the example, a teacher is teaching a kid about a particular thing. Like a teacher is teaching some kind of subject to a kid. The kid learns from that, from the teacher with about that subject, and eventually when exam comes, that kid tests his or her knowledge. So that's how supervised learning works. Apart from this, there is unsupervised learning as well. So unsupervised learning is like for example, a very good example of unsupervised learning is clustering. So in case of unsupervised learning, we don't give the labels to our data. Talking technically, we don't give the labels to our data. Like in case of supervised learning, we give the labels. But in unsupervised learning, we don't give the labels to our data, we don't give the answers. On the basis of the characteristics of data, properties of data, and all such kind of things, the algorithm I would say clusters the data into different partitions. So for example, if I have a basket of fruits, and those fruits are like there's a fruit basket which has mixed fruits, like it has apples, oranges, bananas, three kinds of fruits. So what if we want to separate like all kinds of fruits? So what the algorithm, if there's an algorithm, what it would do, it would like, or what we would do, we would keep the bananas aside, we would keep the apples aside and oranges aside. We differentiate them on the basis of their color, their properties, their characteristics. So that's how clustering works as well. So this is one of the examples of clustering. So this comes under the type of unsupervised learning. So yeah, and the third type of learning, that's also this is a very great research topic these days, that's a reinforcement learning. So in case of reinforcement learning, there is basically we learn from mistakes. This is a very famous tagline used for like reinforcement learning, we learn from mistakes. So there is a concept of a kind of like there's a positive or negative score associated. So we don't expect the algorithm to give the right answer at the first attempt. So what we do is that an algorithm gives an answer for a particular question on a random answer, and then we compare that answer to the ground truth, and there's a and how much deviated that answer is with respect to that ground truth. There's a positive and negative score according to that, and that eventually the multiple iterations help us to like to configure and optimize our algorithm with respect to our like data. So that's how reinforcement learning works. So in today's session, I'll be mostly focusing on supervised learning because I'm working on supervised learning, and it is I really find it interesting. Like we just give it the data, it gets the insights, and then we get amazing, beautiful results out of our algorithm. So yeah. So talking about supervised learning is a type of learning in which we teach or train the machine using the data, which is a well-labeled data. Like as I already said, we need labeled data in supervised learning. We need to tell the machine that these are the answers. So if you are looking at the diagram right here, I would say that, for example, in the blue box, you would say on the left side, there's labeled data which has square, hexagons, triangles, and we are giving the labels for that, corresponding labels at that. Like in the green square at the down, it has hexagon, it is triangle, it is square, and then we are giving the data to the model. The model is being trained, and after training we are giving a test data to the model. So we are testing like how much our model has like learned. So we are giving the square and triangle to this, and then eventually it is predicting it is square, it is triangle. So that's how basically machine learning works. Every model works kind of in the same way. We give it the data, it is trained, we test it with some of the metrics and some of the data, and then eventually our result is out there. So yeah, that's how supervised learning works. So there are also some basic types of supervised learning. Mainly supervised learning is divided into classification and regression learnings. So what are classification and regression? So classification, as its name suggests, classification means to classify something. Like for example, a dog or a cat classifier. It is a very beginner level problem for everybody who wants to get into the domain. So like we give our algorithm some images of dogs and tell the algorithm that these are dogs, and will correspondingly we give some images to the of the cats to the dog, and we tell the algorithm that these are like cats. So on the basis of that learning, the algorithm classifies it like that, this is dog or this is cat. So that's how classification works. And apart from that, regression is there. So regression also is like it's not classification, it's like prediction of a continuous variable. So for example, I have included that example in my further slides as well. So in regression, what we do is that like we need to predict a continuous value. For example, we want to predict the house of the price of a house. So that's a continuous value. A price of a house could be 100, 101, 102, 1 lakh, 2 crores. So that is a continuous value. So when we need to predict the continuous value in a use case, that comes under the category of regression problems. I've included an example out here in the slides as well. For example, what is the temperature going to be tomorrow? This is a regression problem because the temperature value can be continuous. And classification problem I have included, will it be cold or hot tomorrow? So here it is a classification problem, like will it be cold or will it be hot? So it's like two classes are there, cold and hot, and accordingly the weather would be classified. So this is the basic and key difference between classification and regression. So yeah, these are some of the analogies and examples where you would better understand how classification problems are and how it work. So classification, as we know, is a type of supervised learning. So here I have included a beautiful example of email spam classification. So we all use Gmail, right? So Gmail is an important part of our life these days. So what we do is that, like, whenever an email comes that is kind of spam or malicious email, it's already sent to the spam folder, right? So there's a proper machine learning algorithm working at the back end that is classifying these emails into spam or not spam. So what we do, there's a like a there's a mechanism at the back end proper where we do text summarization, then we classify that text and stuff. But there's a proper machine learning algorithm running behind. So it's beautiful. Like whenever an email comes, it checks the content of the email, and if it finds that it is spam, it sends that to the spam folder. So here again, how it is a classification problem? Obviously it is a classification problem because it has two classes, spam or not spam. If it is spam, it would send into the spam folder, and if it is not spam, it would it would be in your inbox probably. So yeah, one of the examples of classification problems is this email spam classification. Okay, so here is a very classic example of regression problems. So, like regression problems, as I told you, we need to predict the value of a continuous variable. So, housing price prediction. There is a very famous and classical data set out there. If you search it out on Kaggle, it is Boston house price prediction. So here, what we get is we get some data, what in the form of features, that would be like beyond the scope. If I chalo, let me put it like this: there are some features or variables on which our prediction depends. So that whole data is given to the algorithm, like what is the area of the house, what is the location of the house, how much away is the hospital from the house. These are the features given which are in the data, and based on these features our price depends on these features. So we need to predict the price of a house based on these features. So when we are predicting, again we are giving the values of these features, and the algorithm will predict like this would be the approximate price of the house. So yeah, here we need to predict the main continuous variable. That's why it is a regression problem. So yeah, this was a brief introduction, a brief deep dive. I won't say deep dive, but yeah, a brief dive into the world of machine learning. Now, talking about what are the real world application of machine learning? See, frankly speaking, machine learning is everywhere. Where there is data, there is machine learning. Reason? See, these days we are sitting on a pile of data. Every day billions, trillions of gigabytes of data is being generated each and every day, be it from social media, be it from other sites, be it from internet generates data in a rapid manner. So where there is data, there is machine learning, not a doubt. Because see, these are the examples which I've jotted down here. But if I talk about industries, healthcare industry is there, then markets, then business. A lot of companies in the IT are investing greatly in machine learning because they really want to get the insights out of the data and solve business problems. So that's great. So as I said, where there is data, there is machine learning. So these are some of the industries I have jotted down: healthcare, education, marketing, small businesses, e-commerce, public relations, recruitment, and human resources. So talking about some of that, like in healthcare, there are a lot of things which are being done with the help of machine learning, like cancer classification. There are images on the basis of image analysis and image prediction. We predict like these with the help of these cells, if these are cancerous or not. In healthcare, they are used in this way. In terms of education industry, a lot of things are being done with the help of machine learning. My final year project was also based on machine learning and computer vision, and it was based in this industry. Like what my project does was it evaluated the attention of students present in a classroom with the help of computer vision and a video feed. So with the help of that attention level of students, we can do a hell lot of things with it. Like we can drive better teaching methodologies, we can do some improvements in teaching practices and stuff like that. So yeah, in education industry it is also being used in a great manner. And yeah, in every industry it is being used. As I told you, where there is data, where there is need, there is machine learning. And yeah, talking about recruitment and human resources, out these days, whenever you submit a resume on a company's website, there's an AI based system out there which like a lot of resumes come to their back end. So an AI algorithm filters out their resume according to their job requirement or job description. And apart from that, there are AI based interviewers these days. Like an artificial intelligence system can interview you maybe in the near future. Like work is going on, and some people have implemented it well, is as well. So in human resources and recruitment, this is how AI is and machine learning is contributing. So yeah, talking about the crux of this workshop, the main purpose was like tools you need to get a kickstart. So people see, we have all, like when I was a beginner, I just also had heard the term that machine learning is a great technology, it solves a lot of problems, but I really wanted a kickstart, and I wanted like, what should I learn, how should I learn? So I would say that like these are some of the tools I have jotted down. If you could like get a hand over these tools, it would be really easy for you to move on. Like, see, at the end of the day, it's our hard work and interest which leads us somewhere. But we need to have some tools, some kind of weapons in our arsenal, so that we can lead in the right direction. So these are your weapons, I would say. These are your kind of tools and technologies which if you would keep handy with yourself, you would definitely get a lot of help and comfort, no doubt. So first tool is Python. See, you have to pick one programming language if you want to get into this field, because you need to code, you need to get the data. For scrapping, you also need to get the data and stuff. That's like a lot of things to do. So in the current market, there are languages like Python and R. But you can learn any of this, but personally I prefer Python, because even if I got started with the machine learning, before that I was comfortable with Python. So being comfortable with Python led me to choose Python. And Python is a very powerful language. It really does wonders when we are dealing with data. It just brings wonders out of the data. So it has a lot of great frameworks which I'll talk about. So Python is the first tool you need first tool with you, that's Python. And second thing that comes is a very good user friendly IDE. There are a lot of IDEs in the market, talking about PyCharm and other, all are good. Every IDE is good, but personally I prefer Anaconda. Reason being, Anaconda does a lot help for a developer. Anaconda provides, like, it's for like people who don't know what Anaconda is. Anaconda is basically an IDE kind of setup which provides you like editors, which provides you all the environment. You can create virtual environments inside Anaconda. It installs a lot of packages for you pre, so that you don't get to fix behind the dependencies. So Anaconda is a great tool. Like, it would give you an IDE like Spider, it would give you Jupyter Notebook for data analysis, it would give you give you the privilege of making virtual environments as well. So Anaconda is the second good thing you need. And Anaconda is really, if you have Anaconda with you and you are on the path for data science, you are good to go, trust me. And after that, you need some data analytics and visualization tools like Pandas, NumPy, and Matplotlib. See, when we are into machine learning, at the end of the day, we are dealing with data. Like, if there is data, there is machine learning. So we need to do data cleaning, we need to do data analysis, and there are higher level terms like feature engineering and stuff. So basically, we want to get the insights out of that data. So for that, we need some frameworks. Like Pandas is a well-known framework for data analysis. We can bring the insights of the data. We can visualize. We need to visualize the data as well to see how the trend is going. So that can be done with the help of this library called Matplotlib. So these are some data analytics and visualization tools which would help you if you are going on the path of machine learning. So yeah, Pandas, NumPy, and Matplotlib. These are gonna be really helpful to you. And yeah, and talking about the machine learning models, this was the pre-machine learning where data would be there. You need to deal with the data. After that, like when you are building a model, so there are a lot of frameworks for this as well. Like PyTorch is there, the latest being PyTorch. TensorFlow is there, Keras is there, and a lot of frameworks. Initially, there was Cafe, which was used. But the very basic framework, since this workshop is for beginners, so very basic framework which you should get started with and start learning, that is scikit-learn. Scikit-learn is an amazing framework by Google, and you would really find great models inside it. You can create a model with some code, and then you can do train test split, which you need to do in data eventually. So that can also be done with the help of scikit-learn. Yeah. So And last thing and last tool which you need would be a will to learn, I would say, because at the end of the day you really need a will to learn, because if you're learning something, you're updating something, you need to work hard, and you need to have that will to learn. So yeah, these are the some of the tools which you will need to get started with this machine learning thing. And yeah, how to get started? So I would see that, as I already told, pick a programming language. You need to pick a programming language, as I told, Python or R, it's your choice. But I would prefer Python personally. Personally, I prefer Python. You can do anything. After that, you need to pick a course for machine learning. Reason being, like, obviously if you are a beginner, you want someone to teach you. You want, like, that if you get some content, you get some basic idea in a structured manner, that would be really great for you. So you need to pick a course for machine learning. Talking about myself, I started with this famous Andrew Ng course by Stanford University, by Professor Andrew Ng on Coursera. You can begin with that, but I was like, I'm not aware of the updated content, but the time I did it, that was in Octave. Octave is just like a language like MATLAB. So, but in the current industry, Octave is not used that much. So you need to eventually get to the Python. So you can do like, but that's an amazing course. Like, that is a course where I learned so much that, like, even today, if I hear a new term, I don't feel lost, because I have heard that term one time or the other time in that, with the help of that course. So that's also a great course. But I have listed down a course in the next slide as well. I'll tell you about. But you need a course, because if you are a beginner, you're a total beginner, you need some content, some basic push would be provided by that course. So you should pick a machine learning course. And talking about the open source and other kind of courses, you can go for open source or paid courses. That totally up to you. But personally, I prefer open source, because I love contributing to the open source, and I have learned a lot from the open source. So yeah, open source courses are there as well. I'll tell you about that in the next slide. So yeah, you should pick a machine learning course. Third thing is read blogs. You should always read blogs. See, whenever you do a course, for example, let's take the example. I did a course video today. I studied a topic today. Then it's very good if I read a blog about that topic, because blog writing, the people who write blogs, those are also amazing, because they help the community and share the knowledge. And by reading blogs, we really get to know a lot of more details about that particular thing. So yeah, you should have a habit of reading blogs every day. After that, solve problems. So see, problems is like, you should start implementing basic stuff. Like, I won't say make a project, obviously, just in the beginning. Just write small code snippets. Like, if you're picking Python, write some snippets, write a function. If you are thinking about a long-term project, write a basic function for that project. So like, solve basic like miniature problems in the beginning, so that, like, solve those problems. That is really going to help you with respect to implementation in long run. After that, make projects. Yeah, projects is something that you really need to make. Only then, like, all this mehnat or all this hard work would come into place. Because why are we working? We all are working, right? So we are working to solve the problems of people. Like, in the industry, every industry, IT industry or any kind of industry, people are working to solve the real world problems. So you should make projects and solve the problems out there. So yeah, that's how we do. Okay, so I have listed down some open source resources. So if you like open source, you can definitely go for that. There's a very good course by Udacity that's free. That's for free of cost. So that's Introduction to Machine Learning by Udacity. I also took that course when I was a beginner. Like, I also did watch some of these videos and like that. So yeah, you can take this course by Udacity. That's really amazing. Blogs, Medium blogs are the best. Like, you read a Medium blog, like, I would say one Medium blog a day is very good for beginners. Like, you should always read that. You get a lot of help from the Medium blogs. A lot of websites are also there, but Medium has great content for data science. So yeah, you should read blogs. These are open source. Some courses are there. I have listed down this Coursera, a course by Professor Andrew Ng. That's also amazing. I personally started with this course. So yeah, this is another thing. And another thing is Google Colab. So what is Google Colab? We all know that, like, for machine learning and these kind of computations, if we are training a model, we need high computing power. Like, we need GPU, we need high processing CPU, like graphical processing units, where this computing can be done easily. So everybody doesn't have that. If you're talking about me, at like when I was a student, I had a basic laptop. So you can't do the training on your laptop. Even if, like, even a GPU laptop won't be good for training deep neural networks or machine learning models. A workstation is needed for that. So being students, we don't have that, right? So we can make the use of open source resources. There are a lot of cloud resources are available as well. Like AWS SageMaker is there, which can be like used for training the models, using the computing power over the cloud. That's how AWS SageMaker works. But the open source resources is Google Colab. I also use this these days. Even I use this. Google Colab is an open source resource where you can use the graphical processing unit over the cloud. That's provided by Google. So yeah, you can use Google. And another important thing is GitHub. GitHub is every developer's friend. Like GitHub is the Facebook for developers, right? So GitHub is amazing. You should go there, read some problems, read the code snippets, see people's code, understand the code, and do stuff. I would definitely not say that don't copy paste. Copy paste is not the solution. You should just try to read other people's code and then understand that code and eventually use that understanding to improve yourself in the implementation part. So yeah, GitHub would be a great friend for you. And a quick tip, I just have a quick tip for everybody of you. Like always apply your knowledge and get your hands dirty by doing projects and solving problems. See, whatever how much theory you learn now, that won't be up to the mark until you implement it. If you are not implementing stuff, you are really not progressing. So once you are done with all that, like all the, I won't say all the theory, because there is a notion of mathematics behind machine learning if you want to learn. But once you're done with basic theory, you just need to get along and start implementing stuff. So regarding implementing stuff, I would say that, like, first start by having by solving basic classical problems. Like there are a lot of classical problems. If there's a website called Kaggle, if you must be aware of it. Kaggle is really helpful for data scientists or students out there. So there would be very classical problems like diabetes prediction, house Boston house pricing prediction. Apart from that, there is like company sales prediction and a lot of problems. The iris data set is there, where we need to predict the class of a flower. And there are talking about a brief, there's a data set called iris classification. So it has four features: sepal length, sepal width, petal length, and petal width. And on the basis of four features, we classify a flower into three of the classes. One is setosa, one is virginica, and one is versicolor. So yeah, that's how we do it. It is a classification problem. So you can solve some of these classification problems in the beginning, because see, in machine learning you are dealing with data. So you need to get the insights of the data. You need to learn the nitty gritty of the data. These things you can done with the help of classification problem, and then eventually you can build models and do stuff. So yeah, this is a quick tip. And yeah, this was all about this workshop. I hope I was able to do it. I didn't bore you much. So yeah, thank you. Happy learning and happy coding. So yep, now I think
Yeah,
we can
yeah.
take questions if needed. Are there any
Just
questions in the comment box?
just a minute, Arpita. First of all, I would like to thank you for such an amazing session. You guided
Thank
all
you.
the
My
students
pleasure.
out. Yeah, you guided all the students out there, like a basic roadmap how they can
Yes.
start the ML. And yeah, as
Yes.
I conducted one poll during your workshop, that how much of them are beginners. So basically, 90% of the students attending the session are beginners, and I think
Okay.
this is the perfect workshop where you had gone like start, or you can get a boost for your further journey in ML. And yeah,
Yep.
so I want to just clear one or two things, that yeah, the students who have attended the workshop, I am going to share the certificate link in the comment section. So you
Okay.
can there will be a small quiz conducted over there, so you can attempt the quiz, and you all will get certificate no matter what your score will be. So before passing the certificate link, we will have a small Q&A section, and if you miss the certificate link in the chat section, then you can come back to this video in the YouTube channel of Code Warriors, and you can go to the description of the video where you will find the link of the form. So yeah, for certification, this quiz is compulsory for all, and the deadline to submit the quiz is till today 10 p.m. And for as Arpita told you all that she mentioned some of the project like IRIS dataset and all. So we have a series of projects for you all. Wait a second, I will share the link in the chat section right now. Just a second. So you can go through all those projects and you can get a basic ideas how the projects in ML are done.
Yeah. And
Yeah.
Mayank, I must say that you are doing great job. And I'll really like to thank you for giving me this amazing opportunity so that we collectively, and Code Warriors is really doing an amazing job for by helping the tech community out there. And so thank you, and that's really amazing.
Yeah, thank you, Arpita. That's all because of the support of all the tech geeks out there. We can organize a session with a brilliant collaboration with such some brilliant speakers like you. So yeah,
Yeah.
guys, now you can share your question on the live chat. So we can proceed with the questions as Arpita will answer the question.
Yeah, but I'll try my best to answer the questions. Please do share your questions.
Yeah, Arpita, you can see the questions in the live. Can you see the live chat?
Wait, I'm not able to see any questions out there in my on my screen. Yeah, yeah, yeah. Okay.
Yeah, there
So
are some feedbacks as of now.
yeah, so
Yeah,
there's a
here is the first
question
question.
which okay, I'm able to read which programming language we should choose, Python or R. So it is basically up to you. I am saying both languages are in the market right now. I personally prefer Python because I feel that there is a lot of helpful frameworks in Python which can help us to deal with data. But yeah, yeah, you can prefer anything on your personal choice. If you're comfortable with Python, I would suggest go for Python. Yeah, role of ML in cybersecurity. Yeah, role of ML in cybersecurity. I just said that where there is data, there is ML. Okay. So if there is, I wouldn't say that cybersecurity is a domain where you deal with security and kind of stuff. You deal with like the authentication of the data and the people, security of the data. So that core principle is done by cybersecurity. But if there is data about some of these aspects of cybersecurity, and we need to get something out of that data, then ML is there for sure. If and obviously data is there. For example, there would be data like what are the what kind of people, there's a pattern from the data, what kind of people are hacking the system, or like what is at what time of the day most of the DDoS attacks occur or stuff like that. So then we can organize data, structure data accordingly, and then ML is there for sure. Okay, okay. So someone is saying that what is the difference between machine learning and deep learning? See, the name of the guy is Rajkumar. So yeah, hi Rajkumar. I would say that see, both are the aspects of artificial intelligence. The difference is that, like in case of deep learning, in machine learning there are a lot of algorithms. Like there is k nearest neighbor, regression, classification, uh, PPCA, principal component analysis. There are a lot of algorithms. But in case of deep learning, we specifically use one algorithm that's called deep neural network. So why it is called deep neural network? It is obviously there's a reason attached to it, because in neural networks we have some neurons, we have some layers. So when there are a lot of layers attached with a particular neural network, then it is called a deep neural network. So yeah, that's the basic difference. That in case of machine learning, we are using a lot of algorithms. In deep learning, we mostly focus on one kind of algorithm that's called deep neural networks. And deep learning is also used a lot in these days because the accuracy of deep neural networks is really really amazing. So yeah. Okay, so would you please share the today's slides? Yeah, I will definitely. Mike, I think I would share the slides with you, and you can pass on the slides to the students. Is that okay?
Yeah, guys. So just a second. Yeah, guys. This slide will be available on Commoodle from where you registered for the this workshop. So basically, whenever after 1 month, 2 month, or any time you come back to Commoodle, you can get these slides, the slide that Arpita presented over there. So yeah, Arpita, you can continue.
Okay, yeah. So next question is, what about statistics in machine learning? Do we need a deep knowledge about it? See, this is a very good question, I would say. वैसे तो I thought कि beginners would be there, but this is a very good question. See, if you are studying machine learning, for some time, if you are a beginner, you need to get the nitty gritty and stuff. But if you want a deep dive, you need to go to the mathematics behind it. Apart from mathematics, there is no machine learning, I would say. So agar there is no mathematics, if you don't know mathematics, if you don't learn mathematics, there would be no fun of learning machine learning. So when you're done with basics, you need to jump into the mathematics behind it. So there is a lot of mathematics involved, like linear algebra, statistics, and calculus, and some probability out there. But since the question is about statistics, so yeah, you need to learn statistics a lot. See, when I worked in my internship, I had to do the cleaning part of data and the analysis part of data, and eventually the feature engineering part. So that can only be done if you know statistics. So statistics is really important. Like, statistics is what it is. When statistics is something bringing insights from that collection of data. So if you for machine learning, statistics is a must, because we are, at the end of the day, we're dealing with data. So you must know statistics for machine learning. Yeah, the question is, do we need deep knowledge? Say you need deep knowledge, because it's not like you would just read mean median mode or like a central limit theorem and you're done with it. No, you need to understand statistics with respect to your data. When you, at the end of the day, you are dealing with a data set. To bring insights out of that data, you need statistics. So yeah, you need a deep knowledge. Please, okay. So okay, can you please repeat the open source resources? वैसे तो there are a lot of open source resources, but in the slides what I mentioned, there was a course by uh, introduction in by Udacity. That's a very good course, you can go. There is a ML crash course by Google developers as well. That's also a good course. Apart from that, I said that I started with Coursera machine learning by Professor Andrew Ng. You can also go with that, but yeah, that has one drawback of Octave. I don't know about the updated content. If that's updated with Python, then definitely go for that Professor Andrew Ng wala course. And there are a lot of courses, but Udacity wala course is really good for a beginner. That's why I listed it down. And open source resources, other were GitHub, other were Google Colab, as I said, computing power which you need for models and all. That's Google Colab. GitHub is there. Kaggle is there. I may not have listed down it here, but I would tell you, Kaggle is an amazing source for data sets, for data science competitions, and for solving the problems. Kaggle is also there. So Kaggle is an amazing open source tool. Yeah, again the question repeated. What about statistics? Yeah, I told this. And what is EDA? People are quite sharp here. That's amazing. This is a very good question. What is EDA? EDA is basically exploratory data analysis. So what is it? See, I did a project in my former as a machine learning intern. I basically learned a lot things about EDA there. So what is EDA? Its full form is exploratory data analysis. So what you can do when you get data, you, without a data scientist or a machine learning engineer, data is nothing. And trust me on this. It's just like data, a piece of paper, an Excel sheet, and nothing. But when you give that data to a machine learning engineer, it turns into gold, because it brings such insights out of it. So EDA is basically, as the name suggests, exploratory data analysis. So what we are doing is that we are taking that data, we are doing analysis on that with the help of pandas, with the help of statistics, with the help of visualization tools like matplotlib. So there are times when we need to visualize data as well, when we need to see how the trend of the data is going, like what is the frequency of this kind of outcome. So you can get a lot of insights out of that. So yeah, you can this is exploratory data analysis. And why exploratory data analysis is useful? The reason being that, like, when you do exploratory data analysis, you get to know a lot of you get to know your data in and out, and that is eventually helpful for feature engineering, which is another process in machine learning, where the feature engineering is basically a process where we choose some top or particular features which affect the accuracy of our model, like which are really important for the prediction part. So exploratory data analysis eventually helps us in feature engineering. So yeah, this is exploratory data analysis. I hope I was able to answer that. Wait, let me take the other question. Just a second. Okay, so okay. What is the best platform to learn about ML? Google, Coursera, Udacity, Kaggle, GitHub. These are the platforms I am using. You can also use. Otherwise, so there are paid sources as well. Yeah, like so Advisor is there. Simply Learn is there. These are paid resources. But talking about open source, Coursera is the best. Like some people would say that like Coursera is not Coursera is paid, but if you have some financial issues, there is an option of financial aid, and you can go for that. So you can go for a financial aid. If they find your application suitable, they would issue you financial aid. So yeah, Coursera is there. Udemy is there, but personally I prefer Coursera, Google, GitHub, Kaggle, Yeah, these are the best open source resources. And medium blogs play a really important role. Okay. Ma'am, please, yeah, don't call me ma'am. I am okay with Arpita. We uh, we are use machine learning in Java. See, machine learning to वैसे is a very broad technology. So machine learning and data. See, there are some aspects of Java in machine learning and data science as well. For example, there's a framework called Hive, which is used for data science. So yeah, you can do machine learning in Java as well. But yeah, most part of it is like if you go to the programming and that part, like there are other tools in Java as well. Hadoop is there for big data analysis. Hadoop is there. Hive is there. But yeah, if you are talking about like core machine learning and stuff, that's basically Python and R. Okay. From where can we learn these topics you mentioned, like calculus, statistics, and higher level? See, this is the question. This was my question even some time back. So, since you mentioned three things, I'll talk about this: calculus, statistics, and higher level. Calculus. See, there are a lot of resources for that. A lot. Obviously, you need to choose them. So, for statistics, I would suggest one source which I also use and I'm even using. That's Khan Academy Statistics on YouTube. That's really great. About calculus and linear algebra, there's a channel called Three Blue One Brown. That's a channel of a great mathematician. So yeah, there are two playlists: the essence of linear algebra and the essence of calculus. So you can go through that. That would really give you a kickstart. So that are good. And talking about statistics, there are a lot of courses available on Udemy, on like data analysis, वगैरह, on like Coursera. So yeah, you can go for that as well. But for statistics, I would say you can buy a book as well. You can buy a very good book. Like there is a mathematics book called Mathematics for Machine Learning. That's also a great book. Or there's a book called Data Analytics by Business Analytics by Dr. Dinesh. That's written by some professor of IIM. So that's also a great book. So you can see there are a lot of resources, but you eventually have to choose what kind of resource works best for you. But for statistics, I would suggest Khan Academy, and for calculus, I would suggest Three Blue and One Brown channel on YouTube, keeping the open source in mind. So can we do ML with C++? See, that again goes with the Java question. There is some part of ML called computer vision that you can do with C++ because there's a very renowned library called OpenCV. That's an amazing library for computer vision. You can code for that library with the help of that library in C++. But yeah, if you are talking about the industry and like industry specific stuff, it would be mostly in Python or R. So yeah, Python and R are the things. Could you suggest us some YouTube channels also to learn ML, as there are many channels? Yeah. So the channels which I personally follow, I'll tell that there is a channel of Krishna Sir on YouTube. I am also learning each and every day. I'm also not a pro at the end of the day. I am also learning, and everyone learns every day or on every day of their life. So I follow Krishna Sir's channel. He was a chief data scientist at Panasonic India, and currently he is into his entrepreneurial journey right now. So his channel is really amazing. Apart from that, Scentdex is a channel that's also amazing. Apart from that, as I told you, like Three Blue One Brown, that's a mathematics channel, but there's a playlist called Introduction to Neural Networks. Neural networks is all about mathematics, so that's also really great. So broadly, there are a lot of channels like Simply Learn and stuff. You can refer those videos as well. And but apart from that, there are the best channel, which Indian channel I would say Krishna X's channel. And if you see for any out of India channel, that like any other person's channel, that would be Scentdex. That's also really great. And yeah, these are the channels I follow. What are some of the projects you have done? So yeah, in my bachelor's, I started with some basic projects like heart disease prediction and stuff, followed by like there were a lot of projects like I did diabetes prediction. Then I did this MNIST dataset classification. But then I finally by like face emotion recognition. After that, I moved to my final year project. It was a research based project. So that project was basically evaluation of teaching effectiveness by video streams from camera. So that project was also shortlisted in top 15 projects all over India. under CSI INAP National Product Awards. So yeah, that project basically used to evaluate the attention of students present in a classroom with the help of computer vision and machine learning. So these I have done. Apart from that, I have also done a project in my internship, but that I'm not supposed to disclose the details out here because I have signed an NDA agreement with them. So yeah, that is something we follow. That's called work ethics. So yeah, I have done this project. And apart from that, I also I have done this machine learning engineer nano degree as well. So maybe there were a lot of projects like classifiers and other kind of things. That all is on my GitHub. You can have a look. And apart from that, I'm also implementing other stuff that I will put on my GitHub, and you can have a link. Probably I'll share my GitHub with Mayank, and he can share with you. Yeah. So what is supervised learning? As I told you earlier, in supervised learning, the basic essence is that we give the labels to the data ourselves. Like we give the answers of the questions, the algorithm learns from it, and then we just get the like patterns out of it, and then the algorithm predicts for the other kind of data. So yeah, what is PCA? PCA is basically principal clustering and principal component analysis. It is an algorithm in machine learning. It is basically used for dimensionality reduction. Again, if I try to explain dimensionality reduction, that would be a hell lot of stuff. So yeah, but it is used for dimensionality reduction, and it is purely based on linear algebra. For whenever you want to validate yourself, if you want to that you know well enough of linear algebra, you should always implement principal component analysis. That's purely based on matrices and linear algebra. So yeah, how is machine learning useful in mechanical? In mechanical, like I don't know the scope of the question. Like in mechanical engineering or stuff. See, in mechanical industry also machine learning is being used. अगर वहाँ data है तो वहाँ machine learning है और data हर जगह है, no doubt. So machine learning is used. Machine learning is not a specific technology, I would say. Machine learning is solving a problem with the help of data and some algorithmic power. So wherever there is data, there is machine learning. So do we need to learn these topics, statistics, calculus first to start with Python? See, this is a very good question for a beginner. I also face this. See, the thing is that you just get started with the theory part, like basics, how things are done in machine learning. That's how I structured the whole presentation. The scikit-learn and stuff. When you are a beginner, na, you need to get your theory and basics strong. When your basics are strong, when you are able to solve this classical kind of problems, na, iris data set and stuff like that, then you can move out to mathematics. When you are able to implement these classical problems with the help of pandas, numpy and stuff, iris data set, house pricing prediction and stuff like this, then you can move out to mathematics. You can also study in the early if you want, no doubt about that, but I would suggest that if you're bilkul like totally starting from scratch, then get familiar with the technology first, how things are done, why things are done, what are the kind of things which are done, what are the algorithms being used, and then you need to deep dive. Like maths cannot be avoided in machine learning at all. Like if you like one of my friends recently posted on LinkedIn, he just at the end of his post he just wrote, I have accepted maths in my life, because really maths really cannot be excluded from machine learning. So yeah, you need to know maths. It's your choice, you want to know at the beginning or the end, but I would suggest that first get a taste of the technology first, and then go deep dive into the mathematics. Can you share some of the job opportunities? See, I can't share some of the job opportunities, but I would say that like keep applying on LinkedIn, Naukri and stuff like this. You can get internships as well. For a fresher level, you can get internships. So yeah, you can see LinkedIn is the best platform. You can search there. How much time a non-IT student need to learn complete data science? See, I would say there's no IT, non-IT. If you have a will to learn, you can do everything. So you just need to have a basic knowledge of programming. Every else thing is, see, maths you have learned in your high school, right? In your engineering, you must have learned engineering maths as well. So कोई time वाला वैसा नहीं है. It's up to you how quickly you learn, how much amount of hard work you put. So don't keep this like thing in your mind that I am an IT student or not IT student. If you want to learn it, you can definitely go for it. Just have a basic programming. If you know C programming, if you know any kind of programming language, you have that like the basic logical thinking with you, then you can definitely go for it. Can we do freelancing with the machine learning skills? Is there a market for those who opt for it? See, you can do freelancing. There are platforms like Upwork and Fiverr, but there's a thing that your profile needs to be solid for that. Like your profile needs to be good. Only then they shortlist you, and then you get projects. So if your profile is strong enough and you really want to do stuff, you can do freelancing for sure. Yeah, Upwork. Someone commented Upwork. Yeah, so there is some of the questions here as well. Yeah, it is not completed. Okay, okay. So yeah, I hope we are done with the session, and it was a great thing. And I hope I did not bore you much, and I was able to help. That was my main intention, to help people out there. If you are able to get something out of it, I'll definitely be more than happy, because I love to uh, contribute to the community and help people out there. So yeah, I think we are done. So hi, Mank.
Yeah, thank you, Arpita, once again for such amazing Q&A session.
Yeah.
So, guys, before commencing the session, I am sharing the quiz link in the chat session. Just a second. And quiz link will also be updated on YouTube description of the same video. So you can come back in some time if you want to attempt quiz. But remember one thing, guys, the deadline is 10 p.m. today. After that, you won't be able to submit any responses for the quiz. So here you go. I had shared the link of. I hope you must have got the link for the quiz. So you can go and submit your learning based on the session. And I hope you all had enjoyed the session. And thank you, Arpita, once again for such amazing sessions.
Yep, yep, yep. Sure, I was. It was a great opportunity. Thank you, Code Warriors, for giving this opportunity. And bye, everyone. And yeah, Mayank, I'll share the PPT with you, and you can pass on it to the students. Right?
Yeah, yeah, sure, sure.
Okay. Thank you.
Okay.
Bye, everyone.
Bye, everyone. Thank you.